In this tutorial, I'll show you how to program running lights with an Arduino and then controlled from Ableton with Max for Live. So in essence, you can make them really run to the beat. I now have this thing at 120 BPM, and if I now jank it all up to 200, you see that the lights go quicker. So the green and red light identify the beat. The orange one beats to the measure. And if I now reset it to 120 again, it goes slower. If I stop it, it will stop where it's at, or play, it starts again. All right, so let's get to this. Before I start, a couple things. I connected it very simply. We have an Arduino, but you can, I use here an IT-Duino. You could use any Arduino really for this. And I connected directly to the computer with a USB interface. Then the LEDs are connected to the Arduino, just to the output ports, but I do use per LED about 100 ohm resistor. Don't use one resistor for all LEDs, really use per LED one resistor. And yeah, that's about it. So let's get started. As basis for programming today, I'll use Arduino Ableton Echo. This is a simple program that takes a value from Ableton, sends it to the Arduino, and then the Arduino bounces it back. There's a separate video on this where I explain how this particular code works. So go to download here. We do download zip. Then we'll open this thing up in our downloads. We'll go to unzip. And the first file we need from this is going to be in Max for Live code, and that is this file over here. So you copy it and then go to Documents, and then Ableton, User Library. No, not User Library. User Library, Presets, MIDI Effects, and then Max MIDI Effects. This is where you want to copy it. Now we open Live. And in Live, so I already have a program here. Let me just get that out of the way. In Live, you're going to the Max MIDI Effects. And in the Max MIDI Effects, you'll now see this Ableton Arduino Echo test. So we are going to move this over to a MIDI track. Important, it's got to be a MIDI track. And so that's where it's at right now. It won't work because we didn't program an Arduino yet, so we'll do that later. We want to first edit this code and prepare it. So here on the top, you see 3 round circles, and we're going to press the most left circle to open the editor. Here's the editor. And in the editor, we want to now see the actual code, which we cannot at this point in time. Now at the bottom here, you can't see the bottom. Give me a sec, there you go. At the bottom, you see a couple icons. And the icon that we're going to need is the one over here. That's called patching mode. So we click on that and the thing folds open. And this is now the basis where you can start programming. Before I start with that, I want to point you to a couple of handy things to know. I'm not sure how familiar you're going to be with this Max for Live stuff, but you definitely want to know these buttons here on the right. The top one is a search slide bar where you can just search for functions that we're going to use later on. Then there's the inspector. The inspector we'll use when you have buttons or so and you want to change the parameters of these buttons. Very, very useful. Then there's a reference guide where you can see for each function what kind of variables you can use with this, etc. And of course there's the console, which you can use as editor. So those 4 icons we'll use quite a lot. Okay, with that, let's basically start. We want to have the LEDs change whenever the new beat starts and whenever there's a new count. So with every beat and with every measure, that's how I should say it. So now we're going to search here for a function that is called plug sync. There it is. And so you drag it in somewhere and you'll see that plug sync will have very many outputs. So the inputs are always on the top and the outputs are on the bottom over here. And the outputs that we need are the second one, which you can see here is the current bar count, and the third one, which is the current beat count. Now, we first want to just investigate what these things really do. And in order to do that, we also want to use the print function. So we search for print and just drag it in over here. We connect now print to the second blob over here. That's block sync current bar count. And if I now go to the console, then you can see that it just trashes the whole console full with 2. We're still beat number 2, measure number 2, still measure number 2. That's a lot of useless information. We only want to hear once that we're in measure number 2, and then we're good to go. So that's where we need the next function that is called change. And change basically only lets new values go through. So it's a simple filter that we put in between. So I just break, what did I do here? No clue. Anyway, I just break this one over here and put this in the middle and connect the second one again, the measure, to the input of change. And change has now 3 outputs, but we really only need the first one. So the first one now goes to print. And if I now go back to my console over here, yeah, there's a lot of 2 still because it trashed it full with 2. But if I delete it now, you'll see that everything's gone. And if I play in Max for Live, play in Ableton, obviously, go back to Max for Live, then you see that with every count, it will now tell me where I'm at. So that's the behavior that we expect. Okay, so with that, we want to now send the measure where we're at to the Arduino. And we're going to use the exact same send function as I already show over here. Now you can make a sub-function, sub-module to make the program more clean. But for now, let's just copy the whole thing and I'll explain to you what it does. So we take this whole, yeah, let me just take everything with explanation, that doesn't hurt. And I will, though, leave the background for now. So I'll just press Shift background, so deselect that. And then I take this whole thing over. Oh, wait, that doesn't work like that. I always forget it's not program. So Control-C, Control-V is what we need to do. And then here's the code that we need to send it to the Arduino. And we can get rid of that print. So the output of change can now go to the values here, there, and there. Okay, so what do we do here? We could just send the value over, but it's only going to send a byte. And as you might know, a byte is only 256, or well, 0 to 255. So that means that if you have a very long song and you go beyond 255 measures, then it would automatically jump to measure 0 again. For my simple LEDs, that doesn't really matter because any measure is the same measure, so it doesn't strictly need that. But you might have a use of really having the real count, so that's why I take 2 bytes. So that's why here I take the number and I split them up in 2 bytes. That's how I should say it. So one is the lower significant byte, that is this modulus 256, and the other one is the most significant byte. So right shift with 8 bits to get rid of the least significant bit and then send this over. This is good for 64,000 or so measures, so you should be very creative to make a song that's longer than that. Then we want to pass it also with a control value. Why do we need a control value? You could, of course, just throw the number over the fence, but then the Arduino needs to figure out, is this now a measure? Is it a beat count? Or is it perhaps something else you want to control? So that's where it's really useful to have control values. So for this particular one, I'm going to set the control value to 251. You can, of course, use a different number. It's just that I just write a lot of programs and I have this consistency in numbering that I use through them. So my measure count is always 251 and the beat count will be 252. And then there is, as you can see, a 255 packed up over here. And then I pack everything together with a pack 0000 function. So the 255 I typically put in the beginning, so that it's for some sort of reason there be a problem on the serial interface and it gets out of sync. Then it doesn't do trash, but it kind of resyncs quickly because there's not that many 255s you're going to be sending around. So then it just waits until it gets 255 again and synchronizes to it. Okay, so that is basically the code. As said, you can make it nicer with a sub function, but for simplicity, I'll leave it like this. And then we'll go to send to Arduino. Now, don't be misguided with this send to Arduino. This is just the fact that I didn't want to put a very long wire all the way over here because you can see here where my mouse is receive Arduino, receive to Arduino. So that's the same as just running a long wire. Oh, I'm not sure what I did there. So this output of pack goes into this serial A383400 module, and that's of course then the serial interface that sends it out to the Arduino. Okay, so we're pretty much done here for the measure. We can also do the same now for the beat. So just copy paste the whole thing and then take the beat like this and increase this control value here to 252. Now there's one more thing that I like to do. I like my Arduino to know whether or not the program is actually playing. So I could yet send another value over, but the way that I typically do this is that the measure starts counting with measure number 1. And so whenever I press stop, I let the Arduino go to measure 0. Measure 0 means we're not playing. And how we do that is, and I'll move this lower a little bit, and I'm going to delete this over here. We're going to add a statement over here. And that statement now is going to be an if statement. So let me briefly, so you press N for new module. And then you do if and $sign I1. Yeah, that should be correct. So that's the input number 1. Okay. If that is the same as 0, then the output is going to be 0. Yeah. Else, the output is going to be $sign input number 2. Okay, so what this means okay, I see what I messed up. I did capital I and it needs to be a small I. So dollar and then small I and then 1 and $small I2. And then you see the second input also appears. So we have here two inputs, 1 and 2. And so if the first input equals to 0, then the output is 0. If otherwise, the output equals to number 2. And what I now do is the first one is connected to the plug sync. So when the device is playing, it's going to be 1. If the device doesn't play, it's going to be 0. And the second one is going to be equal to the current bar count, like this. And then I can connect it to change. Now I want to see, of course, if this really works. So I take myself another print module. Oh yeah, by the way, you can add print modules here over the search function. But another way to add a print module is just to press N on the keyboard and then straight away press print. That will get you print module as well. And I'll throw it over here. We're now going to look at the interface itself. I'll just briefly close it. And Oh yeah, of course I want to see it after the change, not before. Otherwise we'll spam everything to death here. Obviously the program is still playing, so let me just stop Ableton. And we see 0. That's exactly what we expect. And then if I start playing again, then you'll see that it starts with 1, 2, 3, 4. So that way, whenever the measure goes to 0, we know the program stopped. And then if we say 1, then we know Ableton is playing again. With that, we're pretty much done here. But the last thing we need to do is, of course, save this under a different name, because we still called this thing Arduino Ableton Echo Test. So we'll go to File and then Save As. And this will be a long name on my end because I want to make sure that I'm not confusing stuff here. So it is going to be the Ableton, or Arduino Ableton LED tutorial. Week 1. All right. Now, before we move on, there's actually one mistake that we need to get rid of. And that is by sending data to the Arduino, we kind of copy pasted this, and I didn't really think about it too much. And there's actually one thing different. And that is here, I wanted to make it very simple for users to change the parameters so that you could send it to the Arduino and it would send it back. But in our case, we just want a fixed value. So we shouldn't use this particular box. This box is kind of annoying. It resets to 0 always. And so we just want to get rid of that right now. So let's delete them over here and over here. And instead, we'll just use the same constant value as we have over here. There's 255. So let's go ahead and copy paste that. Move it all the way up here. And of course, change it. We need to have 251 over here. And we copy paste it and it will have 252 over here. And the one thing about these constant boxes is that you need to bang them. Banging is this concept of Max for Life that like, hey, give me your value. So in order to bang them, you need to have this generate bang comment over here. Let's take this bang and put it on the input of this box. And then we can take the output of the 251 and go over to pack over here. Bear in mind that this value has 2 inputs. We need the left input. The right input can be used to change the value, but we don't need that. Also here on the right, we take the bang value, go over here, and then take the output and go to the second input of the pack over here. Now we can check if it's working or not by going to the console, and I can take this print that was just laying around doing nothing and take the input and put it over here at the received to Arduino, that value. That is basically what we write to the serial port. And I can see that my Arduino, Ableton is still playing because we now see that we're writing these packages to the serial port and that they're correct. You see here 255 as my synchronization value. And after that comes then the 251 for change of measure, 252 for change of beat. Another minor thing you want to correct maybe is that at the moment here, I have these control values in the presentation mode. And the reason is that in the presentation mode, we have here control that you can send and receive. But there's two other controls now as well, just hanging out. Those 2 controls are from the text that we copy pasted. So you want to select, you can see as well that it's shared, that it's represented in the presentation mode because it has this purple square around it. So you want to just select it, go to the inspector, and then you can deselect the presentation mode here. Include in presentation mode, nope. And also here, remove it from presentation mode. So good to go here. Let me stop Ableton. And then we're going to the Arduino code. Now the Arduino code, going back to downloads, here you go, is here in the directory Arduino code. So we'll copy this thing. And wherever you have your Arduino files, mine are just in the documents, and then go to Arduino. I'll copy paste this thing in and then go to the Arduino Echo test, open it up. Okay, so this is the Arduino code for the simple Echo program. I'll first do save as, so that not to forget this later on. And here as well, I'll choose the same very long name, Arduino Ableton LED tutorial week number 1. All right, so if we go through this thing, as said, it has 3 basic functions. We have the LEDs that we're going to implement the LEDs that count with the beat count, and one with the measure, and then one for the synchronization, so that we know whenever we get communication that it lights up. And so whenever we do get communication, you want to have it light up for a certain amount of time. That is this connected timeout. And it's now at ½ second, which is easy enough to see with the eye. Then we send 4 bytes, right? 255 is the first one. Then we have the control byte. And then the 2 bytes after that we put together, and that's the actual value. So that is why we have here the byte type 1, that's the 255, byte type 2, that is then the control value, and then value 1 and 2, which is the actual value we want to set it to. And then there's an RX state, that's just a simple state that counts the number of bytes received, and whenever that's 4, evaluates whether or not it's valid or not. So before we go and program the logic, let's do some definitions first. So here on the top, we already have our connected timeout, and we're going to add first the logical, the control values that we defined just now in our Max for Live program. So first one here, define ID song beat. So that's the beat change. That's going to be 252 in my case. If you choose a different number, don't forget to put the right number over here. Then we have as well the measure. So define ID song measure. And that's going to be 251 in my case over here. Alrighty, then as next, let's do the pin assignments. In my case, I have a few LEDs connected here to, for instance, the first LED is going to be number 8. Then can I do Control D with this? No, stupid program. Then the next LED is going to be a 9 and 10. What a surprise. And 11. I also have then an LED for the communication channel that we can identify whether or not we're receiving data. This is not strictly necessary, of course, but it helps debugging. Sometimes the communication channel just doesn't want to go work with you. It's kind of nice to see whether or not it's receiving anything. And as well, we have then an LED for the measure that just pops on and off all the time. Oh, that doesn't really line up nicely, but who cares? Okay, so we've got our LEDs, and as next, we'll go into the code. Good, so we have here our bytes set up, and then of course we'll go into the setup itself. Now, let's see, obviously in this program I use the internal built-in LED, which is LED number 13 for the comms channel. So we can just do a search and replace, and we want to, actually that was not very smart, we want to replace the built-in LED with the comms LED, or at least in my case. So just to replace all, and then that's taken care of. So just so you know, the comms LED is of course then first defined as output, And whenever now communication is received, so we have the serial available, that means that there's actual serial communication going on, then we switch on the LED. If it's off, we switch it on. And then after a certain time, if we don't receive any communication, then it's switched off again. So it's just this little bit of code that's needed to have this LED identify whether or not we receive communication. Okay, so that's taken care of. Now the next LED that we want to do, let's just go straight away into the LED 1, 2, 3, and 4. And the first thing we need to do is, of course, define them as outputs. So again, lots and lots of stuff that's similar. So we have here 1, 2, 3, and 4. All right, now we have output LEDs. And yeah, okay. The best thing would be, of course, that you also, when you set them up, that you set these things to false. So we do a digital write and then put them to false. Okay, that's not strictly necessary, but oh well, it doesn't hurt. Throw them in. Okay, we've got our LEDs over there. And while we're at it, we can as well add the other LED. So we have the LED measure. And also the LED measure is going to be false to start out with, meaning off. Okay, then we need to set the serial to the right baud rate. I have it here at 38 kilobits per second. That's not particularly fast, but for controlling LEDs, it doesn't really matter. If you look at my other videos where I control an LFO or an ADSR, then I try to boost this to a very high level because you want instant response if you control an LFO. But for this LED, it really doesn't matter so much. And it's very dependent on the Arduino platform, whether or not you can support a high baud rate or not. Okay, and then we go into the actual program. Just this micros is just a function that takes the current microsecond, is kind of a time, relative time. And with that relative time, we switch on and off the port that the LED comms that identifies the serial channel. So we won't spend too much time on that. What we're going to dive into now is the serial communication. How does this work? Well, if serial available, so if we receive something from our serial port, then we've upped the RX state. So that means we've received at least one bit, right? And then we're going to switch on the RX state. If we received only 1 byte, I shouldn't say bit, 1 byte, then we need to check, is that first byte also 255? That's the synchronization byte, remember? So if it's not 255, we of course reset and we wait until we do receive 255. Then we know it's valid, or most cases it will be. If we receive the second byte, then this is going to be the control byte. So we write then CC type 2. Could actually rename this to CC control or something like that. Might be easier to understand. That will be then the serial read. So read is just take that byte from the serial port and write this to CC type 2. And then with the third, that is the first portion of the actual value we transmit. So this is the most significant byte. And then the fourth is then the least significant byte. After we received the fourth byte, then we received actually that whole package, right? Remember that we did pack 0000, so pack 4 bytes together. And then here in case number 4, we've received those 4 bytes. So now we can actually do something with it. And oh yeah, here you go. I'd say we have now a control value, which is the CC type 2. And then we have the actual value, which is now the 2 bytes, that is CC val 1 and CC val 2, that we now need to combine to an integer. So I do here bytes to int is this value, and as said, it can go up to 64,000 or so. Yeah, in this particular program, remember, we took the Arduino Ableton Echo as our sample program. So what that does, it just throws it back on the bus to the Arduino. But obviously we don't need that in this case. So I'm going to delete this. And instead, we're going to write our actual program here. So we can now, for instance, see whether or not we send out a measure. So I'll write something like, so we're still in case 4, right? So you see here, case 4, we just had our control and our value, and we can now switch on the control. So we can say if cc, if control is identical to, for instance, what was it, ID song beat, then, so you could actually do a switch here, but I'm not too sure whether or not you can do a switch within a switch. So that's why I just stick to if statements here. It's a bit clumsy, but it works. If now we have an actual, if we up the beat count with 1, then the first thing we want to do is set the previous one that was actually on to 0. So we could, of course, now see where, actually, let's just do that. That's better. We can now do if the value equals 1, then it's the first. Count. So we do digital write the LED 1 to true. So we put it on, and then else if the value is equal to 2, then we're in the second bit. What a surprise. But you can see that this would go wrong, because if I just start to switch everything on, obviously you need to, of course, then switch off the previous one as well. So here, in this case, we want to switch on the first one, and we want to switch off the fourth one, because that was the last one that was on. And in fact, now that I'm thinking about it, you might have a 3/4 of value, how do you say that? 3 count value, or a 4 count, or maybe something other exclusive. So perhaps what is even simpler is to just, it doesn't take so much cycles to switch off ports. So what we could do is in the beginning, we just put everything off. And that way, it doesn't matter if you have a 3 count or 4 count measure or whatever. You can just go here, false, and boink, 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 boink. All right, and then we can just switch on wherever we are. So that should work. Well, almost, if it were a smart editor, that is. And then, so 1 is 1, 2 is 2, 3 is 3, 4 is 4. Make sure you get that right, otherwise you're debugging a long time. Why doesn't that third LED go on? Okay, and that's about it for that. So once we're done with that, I'm not sure this statement is not really needed anymore. Then we can, so there's a lot of if statements, right? So here we check the LEDs, and then the if statement above is where we check on the ID song beat. And so we got to go to where this bracket closes. So you can double click here, and then you see where it closes. And there we say else if, and now we look whether or not the control value that we received is identical to ID song measure. Because in that case, we need to, of course, change the measure LED. And remember that I said, well, if it is 0, then the track stopped. So in that case, what I actually want to have is that if now the value equals 0, I would actually like to have the LED off. So we do digital right, LED measure to 0. Yeah, that's basically it. And then else, so if the value is not 0, but it's some other value, what we want to do is we want to toggle the LED so that with every measure it goes either on or off. So toggling is just, you know, digital right, the LED measure obviously, and we do whatever digital read, whatever the port is, and we invert that. Okay. So that seems to be about it. Let me just briefly check if there's errors in this code. Verify. No. Oh, that's a surprise. Okay. Well, then I just throw it over to the Arduino. Make sure, of course, that you have it configured on the right Arduino version that you're using and on the right COM port. And as well, one important thing when you're playing around with Arduinos and with Ableton, you'll find that sometimes the port is taken. And basically, Ableton steals it. And that's probably also what's going to happen here. So let's briefly go to Max for Live. And there we have this close port that we can select. And then we know for sure that the port's not in use. Then we go back to our programmer and we can now program the Arduino. All right, we're good to go. Let's go back here. And so now everything should be working. We can now do rescan, and with rescan we take the serial port back. I can briefly show you guys the LEDs, and then we can press play. And sure enough, we can now see that we're counting the measure and we're counting the beat. And it's a little difficult to see maybe the yellow LED on the left, but that's the communication interface. So if I now press stop, you'll see for half a second it's still on, and then it goes off. Now what we do see is that the beat count LED is still on while I stop the program. If you want the LED to go off, we need to use that same if statement that we used for the measure. So we could briefly do this to make it complete. Is if I briefly open up the plugin again, go from presentation mode here, then this particular if statement, if we copy paste it, and then connect them the same way. Bear in mind, the first one goes here to the sink, and the second value goes now to the current beat count. Okay, so let me just put this here in the middle that you can see. So the first item is the on-off, right? And the second one is the actual value. And I can save, close this thing again. I always resync just to make sure that we're connected. And if I now give you guys the LED view again and play, and now I stop, then the beat count goes off as well. So I hope you were able to follow this. If you have any questions or comments, just write them in the comments below. As always, likes are well appreciated. And I'll see you then next week, where we're going to spice this up and set more parameters between the computer and the Arduino. And I'll show you as well how to automate it. So, see you next week.